Welcome guys. Yeah, so this video I think it's like the high school level. So basically we are computer sine 15 degree and sine 18 degree. And but we are not allowed to use the trigonometric identity. So no sine 2 theta equals to 2 sine cosine, or to cosine 2 theta is 2 cosine squared minus 1, or 1 minus 2 sine squared. There's no such formula, right? We only have the. So now we go back to the junior high school, and we only know the definition. Okay, so we are only allowed to use the geometrical way to find these two. Okay, and surely if you know the sine 15, then you can get sine 15 is not important. It's not, you cannot get something, right? But for sine 18, you can get the cosine 3. You can get cosine 18, and you can use the identity to get the 36, 72, 54, that kind of degree. Okay, so yeah, it's a very interesting question. Okay, so let's start from the simple one. So simple one is a sine 15. Okay. Yeah, so let's let me just clear this. Okay, so the sine 15. Okay, so we are not allowed to use trigonometric identity, right? So we can. There's no way that we can use. Okay, but let's see. So we have to, let's say this is 30 degree, this is 60 degree. Okay, then if I have this triangle, then this is square root of 3. This is 1, right? Okay, so I produce another triangle which such that this line is the same as this line. Okay, so I can create the 15 degree, right? Okay, then everything will be easy because this is 2. This 2 come from 1 squared plus the square root of 3 squared, right? So this is 2. So from here that and then we can calculate this, right? This is 1 plus 2 plus the square root of 3 squared. Okay, so from here we know that sine 15 is basically this one, right? 1 divided by 1 plus 2 plus square root of 3 squared. Okay, so which is 1 plus 4 plus 3, which is 7, and 4 square root of 3. So you get 1 of square root of a plus 4 square root of 3. Okay. Okay, and yeah, so this is your exercise to prove this is 1 square root of 6 divided by plus square root of 2 squared, and take a square root. Okay, so this is 1 divided by square roots plus square root of 6 plus square root of 2, which is square root of 6 minus square root of 2 divided by 4. Okay, so this is the usual calculation for the sine 15. So we only use we only use idea. Okay, we only use a simple idea to plot some triangle, and then we can get sine 15 degrees. So there's no trigonometry inequality or equality or something like that involved. Okay, and the next is that the famous results about sine 18. Okay, so this sine 18 is very it's not easy to compute, so we need to start from the pentagon. Okay, so yeah, maybe so let me draw a better pentagon. Okay. Yeah, hopefully this. I mean, this looks not perfect. Okay, and this pentagon is a regular pentagon, so each side has the same length. So let's say this length is 1. Okay, and everyone knows, right? So this angle is 108, and then you separate this, right? So these are both 36. Okay, and yeah, and so this is 100, 0, and 8, right? So now so the key is that we want to compute, let's say maybe the sine 18, right? Such, or like cosine 36 or something like that, right? So the key is that we need to find so maybe this video let's try to compute cosine 36. And once we have cosine 36, then we can get a sine 18, right, by just using our trigonometry identity. Okay, so let's see whether we can solve it. Okay, so let's see. So so let's assume that this is x. Okay. Right. So the diagonal is x. Okay. Then let's see. So let's see. Okay. So now let's focus on okay. So this is 1 x, right? And let's see. You see, this is triangle is 100, 0, and 8, 36, and 36. And this small triangle, right, is still 100, 0, and 8, 1, and 1. 36, sorry. So that means, let's see, A, B, C, and D. Okay. So from here, we can see that ABC is similar to ABC, right? It's similar to ABD. Okay, so if this is x, right, then this is 1. That means this is 1 over x. Okay. But okay, so this is 1 over x, right? Because these two, this small one, ABD, are similar to ABC. Okay, and also by symmetry, this 1 over x is 1 over x here, right? It's all 1 over x. Okay, so let's see. So finally, let's see another let's see whether we can get an answer. Okay, so now let's see. So this is 1 over x, right? And then the total is x. So this is yeah, I mean, so every these two are 1 over x. Okay, and let's see. So we have you see here, right? You see here. These are 72, right? These are also, so these are equilateral. These two sides must be the same. So if this is 1, then this must be 1 minus 1 over x, right? So now we have 1 over x plus 1 minus 1 over x plus 1 over x. So we get x equals to this total length, diagonal is x, is equal to 1 minus 1 over x plus 2 divided by x. So it's 1 divided by x plus 1. Okay, so from here we get x squared equals to 1 plus x. So x squared minus x minus 1 is 0. So this is a famous golden ratio. Yeah, so x is 1 plus square root of 5 divided by 2. Okay. Okay, so now everything is happy, because if you focus on this triangle, you get 1, and you get you can take you just separate, so you get a half, and then your x is 1 divided by square, so it's 1 divided by square root of 5 divided by 2. Okay, and this is 36, this is 54, right? So you can start from here, and then you get your cosine 36 is 1/2 divided by this, right? Okay, so you get your answer is basically 1 divided by 1 plus square root of 5, which is the square root of 5 minus 1 divided by 4. Okay, so once you get the cosine 36, then you can get the sine 18 or whatever, cosine 54 or something, right? So you can basically get the 18 basis. Okay, and from here you also know that you know how to plot the use. So now you can start to believe that one can do the regular pentagon, right, by just using the complex and ruler, because the reason is that I mean, this square root of 5 can be done, right? So actually, if one can build the cosine 36, then one can try to build this angle, right? Once you build this angle, then you can get a pentagon, right? Okay, so see you guys next videos. I will see you, and hope you guys subscribe to my channel.